So here's a kind of procedure. You try to find the population mean, for example, the average household income in the United States. And then what you're going to do is randomly sample n element from the population. Well, if you are the social worker to do that, to find the American income, you better to know the demographic of this country. Without this domain knowledge, I bet you wouldn't do a good job. If anybody from China, you come to the States, you say, hey, let me do this social work. I bet you don't know the job. You cannot do good work. You know why? Unless you've been to the big city, right? Chicago and New York and Arkansas, you don't know that. You need to know the country. Then you are not a random somebody. This time you are not going to roll the dice and to see who you're going to draw from the Social Security. That's not the way to do it. Why? Okay. Anyway, think about it. Yeah. So we have all different strategies to do the sampling. I just tell you, you cannot do random number because this country, if you do that, you won't get the right answer about it. You need to go the so-called stripe kind of sampling. We're going to talk a little bit later. When you randomly pick it as a population, and then you're going to calculate the mean of that sample. And then this mean will be used to approximate the mean of this population. Well, for the deviation, that's a little bit different. Usually, the smaller sample you take, the biggest deviation you're going to have. They're going to vary very large. But the more population you take, the deviation could get a little smaller. It really depends. If in the States, you pour the population in the whole country, you say, oh, let's do the random number. Most likely, you are not going to neglect those huge population in the internal city, like in Chicago, in New York. You do not know. Without that, you are not really get a fair learning example. Once you get it, without those examples, your training will be useless. When they handle that, they cannot handle because that's out of the norm. Out of the norm. So that's why it depends on you understanding your data. If you don't, it's hard to do good work. Sampling is step one to make your success or failure. Random is just a simple as long as you get a uniform set of data. That means there's no ethnic group difference, there's no location difference, no income difference, or that's the assumption. Let's say you get an officer in the admission office. And then admission officer try to predict how many people it's going to materialize and be here and become a student, and how many people would go to the dorm. They need to prepare for this many dorms and the rooms. And also you would like to know, based on the income the statistic data, I would predict what's the retention rate the next 4 years. And what you're going to do? Well, the first two are relatively easy. All you need is a sampling and do a education guess. That's pretty good. For example, the SAT score on average. If you got 900 people coming in, I just have about a half of hours. I probably randomly pick up 30 students to see what's the average score of the SAT. And then I'm going to look at another feature. How many of them is going to believe in the dorm? And then usually, you know, live in the dorm, you get a high GPA than those live outside of the campus. Well, you can do that quicker. You also only get 30 people randomly to see, give an estimate. But the real job is, I wanted to use those data to predict how many people were going to be retained in the next 1, 2, 3, 4 years, and how many people are going to have attrition. That's a data mining job. And how do you mine? You get no current data, then you are going to sample the 30 data, look at the historical similar data, and the historical similar data either they dropped out or they continued, and then use that to train the machine to predict the rest of 900. Make sense? Because you got those kind of profile, you categorize the profile based on visualization. We're going to talk next Wednesday. And you say, oh, this is the same thing. The profile is the same attribute, the same range of SAT, the same intention, same family background. And then a first generation or not a first generation student from low income family or high income family, based on those kind of features. You're going to say, hey, this is the profile. I know 5 years ago I had one student here, he finished his master's degree, and here another profile, I know 5 years ago 20 of those dropped out. Those are the training data you're going to make. But the first hand you draw the sampling need to be random. And then you're going to match the profile, you're going to do the training, and you're going to do the prediction. So what you do? So step one, pull the data, maybe have 900. You don't see the people, not sure, but you can look at the Excel file and then spreadsheet. And what you do the first thing is you make 900 a random number. One column, just one function, done, all the way from 0 to 1. That's easy, right? And you make this one column, and then you are going to use this sort operation to make it the random number from 0 to 30. You just pick a 30. You can pick more if you want, but the 30 is good. You use the sort operation. Ascending means from the smallest number to the biggest number, and then you pick a 30 from here. Just bring this table, copy paste, and Microsoft is very powerful. You just highlight this table and click this bottom of the graph. They're going to show you all the histogram and star, whatever you want. And then you can visualize those data pretty clearly. Okay, then you start the calculation. That's the average SAT score. That's done close to a burrito, I guess. To the math and the English, we are a little bit high. And then you're going to look at the standard deviation, the S, that's not quite a sigma. You're going to look at how many people in here want to live in the dorm. That's also your estimate. And that's your data attribute. And what you are going to use that to report to your president. You say, hey, I just got 1 hour, I finished my estimate. I think that the average for SAT is around 1,000, and the 2/3 of the people is going to go to the dorm. And you make this prediction, it won't be too far. And burrito in each year based on those numbers to make our budget. And our budget in the end could be plus minus 1 million, or a little, that's 1%, or less than 1%. It's not bad. And we depend on this to know how much budget we can buy coffee or something. In the end, if you want to look, you could, if you want to see how accurate, basically that's after the things happen, you have plenty of time, you can go back to look how good you are, and then you can come back to look, you may say, oh, the whole population in the 900 people is 990, and the US sample says 997. Well, that's acceptable in some range, the bell shape. If it's anywhere between, it should be okay, not too exceptional. Then your real population, let's say, that's what, the spread, the standard deviation is 80, and the US sample is 75, that's fine. And the 0.68 and the 0.72, we do have those data in the file. If you want, you can play. It's very quick, but a half hour you play and understand what you're talking about. But that's pretty good to save you the time.